Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi. Kita sambung lagi video kita, perbincangan untuk topik seterusnya, iaitu berkenaan dengan first order of differential equation. So kali ini kita lihat sedikit bagaimana kita nak lakukan penyelesaian untuk bila mana kita mempunyai persamaan differential ataupun kita panggil dia nama differential equation. So untuk topik ni fokus untuk kita selesaikan yang melibatkan first order of differential equation saja. Okay, so when we talk about differential equations, it is actually an equations which contain an unknown functions, one or more of derivatives. For example, saya ada contoh kepada differential equation. Contohnya kalau saya ada dy over dx minus 7x plus y equals to 0. So this is actually example of differential equations of first order, di mana kita ada dy dx dekat sini merupakan unknown function kepada equation ni, ataupun mungkin juga kita boleh ada dalam bentuk a second order of derivative. For example, kita ada x d squared y over dx squared plus y dy over dx equals to sin x. So this is also a differential equations, di mana kali ni differential equation kita adalah second order of differential equations. Okay, ataupun banyak lagi lah contoh-contoh yang lain yang melibatkan differential equation. So hari ni kita nak tengok, hari ni kita nak fokus kepada macam mana kita nak selesaikan differential equation dengan menggunakan kaedah separable variable, okay, which is subtopic of 8.1. So let's start with two types of solutions of differential equation in separable. Okay, so when we solve our differential equation of first order using a separable technique, we're going to have two types of solutions. The first one is a general solution. Okay, kita akan dapat general solutions. Okay, so general solutions, for example, a general solution is actually the differential equation with the presence of an arbitrary constant. So kita akan ada nilai arbitrary constant. So contohnya dekat sini kita akan ada y equals to c e to the power of negative 2x, whereby c is actually our arbitrary constant. And how about particular solution? Particular solution is actually differential equation which obtained from general solution, is coming from the general solution, in which the value is assigned to the arbitrary constant. So bermaksud nilai arbitrary constant kita tadi adalah mempunyai value. Bila nilai arbitrary constant kita tadi mempunyai value, then we consider it as a particular solution. So kalau ianya melibatkan unknown variable for arbitrary constant, so kita panggil dia sebagai general solutions. Okay, so let's continue with steps to solve separable variable differential equations. Saya akan kongsikan 3 steps di mana macam mana kita akan guna kaedah separable variable untuk selesaikan differential equation. So the first step is kita nak kena rectify kita punya differential equation. First order differential equation must be in this form. Okay, so dy dx, okay, equals to fx times with hy. Okay, so the differential equations must be almost look like this lah. Okay, and the second step is we're going to separate them, y with dy, x with dx. So kalau kita tengok dekat sini, kalau let's say if I have differential equations dy dx equals to fx times hy, after doing cross multiply product, okay, so selepas saya dapat cross multiply product from this equation, okay, saya akan dapat 1 over hy dy equals to fx dx. And after separate the variables, then the third steps is we're going to do integrate for both sides of the equations. So dekat sini kita akan integrate 1 over hy dy equals to integrate of fx dx. Okay, so let's start with example 1. Find the general solutions of the differential equations dy over dx equals to 3x over y minus 2. So first we're going to do first steps, which is separable technique. Okay, so we're going to separate them, y with dy, x with dx. So kita akan buat cross multiply product. So from here, after cross multiply product, kita akan dapat y minus 2 dy equals to 3x dx. Then afterwards, so we're going to do the second step, which is integrate for both sides. Okay, so y minus 2 dy equals to integrate the 3x dx. So here we're supposed to have y minus 2 to the power of 2 divided by 2. Okay, equals to 3 is actually constant, kita boleh keluarkan daripada process of integration. Just like we have 3 integrate x, we're supposed to have x squared over 2 plus with arbitrary constancy. Then simplify, saya akan dapat y minus 2 squared, okay, which is equals to, so let's say that here saya darab dengan both side with 2. Okay, saya darabkan dengan 2. Okay, so saya akan dapat y minus 2 squared equals to 3x squared plus 2c. Okay, then after that we're going to simplify y in terms of x. So saya akan dapat y equals to 3x squared plus 2c. Okay, punca kuasa, and then plus 2. And lastly for 2c, since this is actually an arbitrary constant, which is 2c, so saya boleh katakan, saya boleh tukarkan dekat sini. So let d is equals to 2c, so this is also an arbitrary constant. So we are going to have y is equals to surd 3x squared plus d plus with 2. So this is actually our general solution. Okay, general solutions of the differential equations of dy over dx equals to 3x over y minus 2. Okay, kita tengok example 2. Solve x squared dy dx equals to 2x plus xy. So now we're going to do the first step, which is separate with x dx and y dy. So what we're going to do is saya akan lakukan proses of separables, but first since we have 2x plus xy, yang ini kita nak kena factorize x dahulu. Okay, kita nak kena factorizekan dulu, di mana saya akan dapat x squared dy dx will be equals to x 2 plus y. So saya separatekan x dengan y for this function x plus xy. Okay, then after I finish this, then baru saya lakukan proses cross multiply, di mana saya akan dapat 1 over 2 plus y dy equals to x divided by x squared dx. Okay, so bila saya simplify kat sini, saya akan dapat 1 over 2 plus y dy equals to 1 over x dx. Okay, after saya selesai this part, we're going to use the second steps, which is we're going to do integrate for both sides. Okay, now we have 1 over 2 plus y dy. So we're going to have ln absolute 2 plus y. Okay, actually it is divided by 1, so since it is divided by 1, saya tak tulis lah. And then equals to 1 over x is become ln absolute x plus with arbitrary constancy. So remember, arbitrary constancy is only we write on the left side. Kita tak tulis di kedua-dua side. Walaupun dekat sini kita lakukan process of integrations. On the left side is with respect to y, on the right side is with respect to x. Tapi untuk arbitrary constant, we just put only one place, which is on the right side. Sebab arbitrary constant ni adalah melambangkan untuk ke semua function tersebut. So memandangkan y dengan x ni dia berada dalam satu function. So cuma kita cuma tulis arbitrary constant ni on the left, on the right side sahaja. Okay. Alright, so saya sambung lagi, simplify ln. So we have ln absolute 2 plus y equals to ln absolute x plus c. Dan apa yang saya akan buat dekat sini, the next step is I'm going to change this function of ln into exponent. Okay, so mana pelajar yang masih ingat how to change from ln to exponent? Okay, this will become, bila saya tukar kepada exponent, dia akan jadi 2 plus y is equals to e to the power of ln absolute x plus with arbitrary constant c. So saya recall balik how I'm doing this. So this concept, okay, so this concept is actually coming from macam mana kita tukar let's say kalau saya ada log ex is equals to b, so this will be equivalent to e to the power of b is equals to x. Okay, so saya menggunakan hukum log yang ini untuk saya tukarkan daripada ln absolute 2 plus y equals to ln x plus c into 2 plus y equals to e to the power of ln x plus c. Okay, so this is plus c. Okay, alright, then I simplify. Okay, so saya akan dapat y is equals to e to the power of ln absolute x. Since we have plus, so saya boleh tukar dia kepada times e to the power of c, okay, which is minus 2. So again, now we have e to the power of c as arbitrary constant. Okay, so kita ada e to the power of c sebagai arbitrary constant. So I'm going to let a is equals to e to the power of c. Actually, for arbitrary constant, you can use any variable a, b or c, any kind of variable you like. But in this case, saya lebih suka guna a lah. So dalam case ni saya memilih a sebagai saya punya arbitrary constant. So let a equals to e to the power of c. Then saya akan dapat y is equals to a e to the power of ln absolute x minus 2. Again, kita tengok, kita refer dekat sini, kita masih ada lagi satu rules of log yang kita boleh simplify, which is e to the power of ln x. Kalau pelajar-pelajar masih ingat, let's say we have ln e to the power of x which is equals to x, ataupun kita ada e to the power of ln x which is equals to x. So you can use these rules in order to simplify. So bermaksud dekat sini, e to the power of ln absolute x is actually on the second tips dekat sini. So bermaksud saya akan dapat y is equals to ax minus 2. Okay, so this will be my final solution ataupun general solution. Okay, general solutions of my differential equations x squared dy dx equals to 2x plus xy. Okay, next on example 3, we are going to look at the particular solutions of example. Macam mana kita dapatkan particular solutions of differential equations. So let's say we have a differential equations of y squared dy over dx equals to minus 3 set x y. So firstly, of course, we are going to do the separable technique. And then after we get the general solutions, we're going to use this y equals to 1 and x equals to 1 in order to get the value of arbitrary constant untuk kita dapatkan particular solutions. So now let's start with the separable technique. So kita akan separatekan y dengan dy, x dengan dx. So in this case, after cross multiply product, so we're going to have y squared over y dy is equals to minus 3 set x dx. Okay, so for this minus 3, it's up to us actually to simplify, untuk kita biarkan negatif 3 ni berada di sebelah kanan ataupun kita nak pindahkan ke sebelah kiri, because it is a constant anyway. Tapi saya lebih suka biarkan negatif 3 tu berada di sebelah kanan, because in the particular solutions ataupun general solutions, normally kita akan simplify dia dalam bentuk y in terms of x. So kalau saya bawa 3 di sebelah kiri, the same thing, I'm going to simplify 3 will be bring to the right side as well. So in this case saya akan biarkan negatif 3 di sebelah kanan. So after simplify, so we're going to have y dy, okay, equals to minus set 3x dx. Okay, so now we're going to do integrate for both sides. Okay, so since negative 3 is a constant, saya keluarkan. Saya boleh tulis, sorry, so this is supposedly x. Saya boleh tulis integrate set x minus 3 will be outside of integral part. So we're going to integrate set x dx, and this one is set y. Okay, so dekat sini saya akan dapat y squared divided by 2 equals to minus 3. So integrate x to the power of half. So half plus 1 become 3 over 2. So 3 over 2 is become 2 over 3x to the power of 3 over 2 plus with arbitrary constant c. So now we simplify. Then we're going to have y squared over 2 equals to 2x to the power of 3 over 2 plus with arbitrary constant c. Okay, then since we are looking for particular solutions again, so at this stage, sebelum kita selesaikan sepenuhnya, kita boleh gunakan equation ni untuk kita dapatkan the value of c actually. Okay, so now we are looking for value of c in order to get a particular solutions. So at this stage, we are going to substitute with x equals to 1, y equals to 1. Okay, so x is equals to 1, y is equals to 1. So kita akan dapat half is equals to 2 plus with c, okay, which is equals to c will be equals to suppose this is actually supposedly minus, okay, minus 2. So then here should be minus, and here will become half plus with 2, which is equals to 5 over 2. Okay, so kita dapat nilai arbitrary constant kita iaitu 5/2. And lastly, kita akan letakkan balik dalam equation kita. Itu kita akan ada y squared over 2 equals to minus 2x to the power of 3 over 2 plus with 5 over 2. And then afterwards barulah kita simplifykan dia. Okay, so kita simplifykan dia, kita jadikan dia y squared equals to negative. Okay, so kita akan dapat negative 4x to the power of 3 over 2 plus with 5. Okay, so this is actually a particular solution. Okay, so this is actually a particular solutions of the general equations, of the differential equations y squared dy dx equals to minus 3 set xy. Alright, example 4, also we are looking for particular solutions. So let's say that we have differential equations dy over dx equals to e to the power of y over set x plus 1, and we have this y0 is equals to 0, means that this is actually x is equals to 0, y is equals to 0, the value of x and y that we're going to plug into our general solutions in order to get a particular solutions afterwards. And let's start with separable technique. So kita akan asingkan x dengan dx, y dengan dy by using cross multiply product. So after doing cross multiply product, we're supposed to have 1 over e to the power of y dy is equals to 1 over set x plus 1 dx. Okay, and then we're going to do integrations for both sides. Okay, so before we start doing the integrations, so kita simplify akan dulu, since dia berada di denominator. Saya akan jadikan dia kepada negative index. So kita akan ada integrate of e to the power of negative y dy equals to integrate of x plus 1 to the power of negative half dx. Okay, so now we proceed with integration. So e to the power of negative y, we're supposed to have e to the power of negative y over minus 1 is equals to this one. We're supposed minus half plus 1 become half. Then we're supposed to have x plus 1 to the power of half divided by half. Okay, and then plus with arbitrary constancy. Okay, then after simplify, saya rewrite again this equation as minus e to the power of minus y is equals to 2 times with x plus 1 to the power of half plus with arbitrary constancy. So in this case, kita boleh substitutekan nilai x dengan y accordingly in order to get the value of c, which is our arbitrary constant. Okay, then substitute x and y. So here saya akan dapat negative e to the power of 0 times 2 times 1 to the power of half plus c. So therefore here saya akan dapat minus 1 equals to 2 plus c. Therefore c will be equals to minus 3. Okay, then saya akan dapat equation dia minus e to the power of minus y equals to 2 times with x plus 1 to the power of half minus 3. Okay, and boleh tinggal jawapan akhir dalam bentuk macam ni, ataupun kita boleh simplify balik equation ni dalam bentuk y in terms of. Okay, so kalau kata students, let's say that you want to simplify, you want to proceed further with y, so I'm suggesting that you do the ln for both sides in order to get in order to simplify y in terms of x. So katakan dekat sini, katakan kita nak proceed further. Okay, saya darabkan dulu negative for both sides. So kita akan dapat e to the power of negative y is equals to, here we supposed to have negative 2 times with x plus 1 to the power of half plus 3, and then we're going to do ln for both sides. Okay, ln, we're going to have ln, so we're going to have ln for both sides, okay, of e to the power of negative y equals to, yang ni kita akan ada ln of negative 2 times with x plus 1 to the power of half plus 3. So remember, this is actually the rules of log. Ln e to the power of negative y, kita akan dapat negative y. Okay, so kita akan dapat negative y sama dengan ln negative 2 x plus 1 to the power of half plus 3, and lastly you akan dapat y is equals to negative ln negative 2 times with x plus 1 to the power of half plus 3. So this will be our particular solutions of the differential equations of dy over dx equals to e to the power of y over z x plus 1.